tallest mountain on Earth, Mount Everest, is 9 kilometres above sea level. And the mean radius of the Earth to the nearest kilometre is 6,378 kilometres. Part A, you calculate the difference between the gravitational field strength of the Earth at sea level and the top of Mount Everest. Part B, then, they want us to discuss whether it's reasonable to assume that the Earth's gravitational field is uniform between the surface and the height of 10 kilometres above the surface. Alright, so let's have a quick think about this. What they're already doing is we're looking at the ground, and we're saying there's surface of the Earth, say sea level, say is 9.81 newtons per kilogram, which is the normal stated value. Now, they're interested in a point that's actually 10 kilometres above the surface of the Earth. So there's 10 kilometres. And you've actually worked out that G, in part A, you've worked out that G here is 9.81 and 9 kilometres up, so about here, the change in G is actually 0.028 newtons per kilogram. And they wanted to discuss whether we could consider the gravitational field to be uniform between 0 and 10 kilometres. Now, 0.028 newtons per kilogram is pretty small as a change. As a percentage change, we've got, it's going to be, so the percentage change is 0.028 divided by 9.81. It's a little bit dodgy anyway, because I don't know what that next figure is, times by 100. Shove those numbers into a calculator. So I've got 0.028 to 8 three times divided by 9.81 times by 100 gives me, we've got, funnily enough, 0.2, I'm going to say 0.29 is pretty much actually divided by 10 effectively. So we've got percentage change of 0.028. So I could have discussed this. So changing height by 10 kilometres from the Earth's surface only changes the gravitational field strength by 0.028 newtons per kilogram, which is 0.29%. Now, because this is such a small change in the gravitational field strength, it is reasonable to assume that the gravitational field is uniform, i.e. G is constant, in this region. And to be brutally honest, that's why we normally actually do just assume it's uniform around the surface of the Earth, certainly when we're working close to the surface of the Earth within the first 10K. Thank you very much.